Welcome again, everyone, to the 2021 Daniel and Irma Evans Endowed Lecture, and in particular, welcome members of the Evans family. Unfortunately, I can't see you, but I hope that there are a few of you here, and welcome. This lectureship provides an opportunity for us in CEE and the broader community to deepen our understanding of civil and environmental engineering by exposing us to new concepts, challenges, issues, and methods that may affect our engineering research and practice. Today, we have the unique opportunity to learn from a panel of 4 experts about tsunami hazard, risk, and mitigation on the Washington coast. We have Representative Derek Kilmer. He serves as the U.S. representative for Washington's 6th congressional district, which encompasses the Olympic Peninsula and Washington's Pacific coast from Westport north all the way to Neah Bay on the point there. He brings our panel discussion the perspective of a longtime resident of the 6th district, as well as his experience as a senior member of the House Appropriations Committee, where he sees firsthand how federal investments enable communities across the Pacific Northwest to become more resilient to natural hazards, including climate change and tsunami. We have Dr. Ann Bostrom. She is the Weyerhaeuser Endowed Professor in Environmental Policy in the UW Evans School of Public Policy and Governance. Her research focuses on risk, perceptions, communication, assessment, and management, as well as decision-making under uncertainty applied to a variety of natural hazard scenarios, including earthquakes, cyclone, and tsunami. She was a member of the committee that authored the 2010 National Research Council report on tsunami warning and preparedness. We have Dr. Dan Abramson. He's an associate professor in the UW Department of Urban Design and Planning, and his research focuses on community planning for disaster recovery and hazard mitigation. Since 2011, he's participated in a series of earthquake and tsunami resilience projects with coastal Washington communities, including the Makah tribe, the cities of Aberdeen and Westport, the Shoalwater Bay tribe, and South Beach, Grays Harbor, and Pacific counties. Finally, we have Dr. Mike Motley. He's the John R. Kiley Endowed Associate Professor of Civil Engineering at the University of Washington. His primary research focus is fluid loading of civil structures. Recent and ongoing research projects employ experimental testing and high-fidelity simulation to investigate the interaction between tsunami waves and 3-dimensional coastal bridges, the interaction between large-scale wave-induced debris fields and coastal buildings and bridges, and probabilistic approaches to improving community resilience. Welcome, Representative Kilmer, Professors Bostrom, Abramson, and Michael Motley. For today's format, each of our participants will speak for 10, 12, 30 minutes, 12, just kidding. And then we should have about 30 minutes for Q&A. We're in a seminar format, so I would encourage you to put your questions into the question box. And if you see one that you like, you should be able to uptick it so it gets closer to the top. And then either my assistant Karen or I will present those to the panel. We're going to start with Professor Motley and then work our way through Professors Abramson, Bostrom, and finally Representative Kilmer. So why don't you go ahead, Mike?
Absolutely. Thank you, Laura. And thanks to everybody for coming. It's great to see so many people here. So can we see my screen okay? Okay, so I'm going to be introducing the concepts, a little bit of what we're talking about today and talking about mitigating tsunami risk on the Washington coast. I wanted to start with this image. I took this picture from the top of the Arahama Elementary School in just outside of Sendai in late 2019. You can see kind of the coast. It looks nice and peaceful and quiet, but on the day of this tsunami, this is what it looked like. So the big 4-story elementary school that's standing here, that's where we were standing on top of. And this building served as refuge for several hundred people within that community. But you can see basically the total devastation and what results from this. And so what we're going to be talking about today is how we can kind of address this head on, mitigate some of the risks that we're talking about, and put together a more resilient community. So in the 21st century, I think we all have gotten more and more familiar with tsunamis. If we look at this highlighted region along the Ring of Fire here, the Christmas Day tsunami back in 2004 in Indonesia, I think is the one that really had people piqued the interest of this is what can actually happen with these things. It kind of got away from this is something that happens in a movie to this is something that really is affecting a lot of people. And then as the years go by, you see Samoa in 2009, you see Chile in 2010, and then in 2011, we get the Japanese event. And so when I look at this, I see a lot of activity over the last 17 years now, and one gaping hole in the ring of fire, right? If we think about what the gaping hole is, that's us, okay? And so I think that the events that have happened over the last however many years since the turn of the century, it's opened a lot of people's eyes. And there were people who have been working on this years before, but I think you've seen a huge increase in the interest in building up our communities, building this awareness, building a better infrastructure, and pushing forward with these issues, okay? And so over here where we sit, we are just out or inside of the Cascadia subduction zone. So this is probably review for many of you, but if not, we're in a very seismic region here in Seattle. And just off the coast, we have the subduction plates that are really the cause of a lot of these tsunami events, okay? And so if we think about, where these different subduction zones are, you can see that this small region up through here puts us in Washington in this hazard position that we are going to have to deal with, okay? And you'll notice here, likely length of the subduction zone ruptured in 1700, all right? And so this is the subduction event that occurred. It's been dated by USGS and relevant researchers to the year 1700, and we are told a return period between 300 and 600 years. So if you do the math, we are 321 years into a 300 to 600 year return period. So the timing is right for us to be really making these plans and moving forward. I pulled this figure, and Ian Robertson and Gary Chalk, as they developed led the development of the new ASCE 7 loading guidelines. So we showed this picture that kind of shows the probabilistic wave height that we might expect along the coast. So what we're looking at here is the exceedance height, so the height of the water, the depth of the water along the coast, measured in meters, along the US coast. So down from California all the way through around through the Aleutians and then into Hawaii as well. And so what these lines represent are the maximum wave height we might expect to see, or the maximum water depth, for an event that happens once every 2,500 years. So that's what the 2,500 year event here means. And from an engineering point of view, that's roughly equivalent to a 2% probability that this would happen in any 50-year cycle. And that's kind of where we are there. But what we see is some relatively constant values along much of the US continental coast, with these peaks that have come here up in the Washington, Oregon region, okay? And this is upwards 8 to 12 meters through here, okay? And I know that sometimes we can, it's hard to put in perspective what this actually looks like, okay? But if we go back to the first picture that I showed, over here is a statue, and this statue at the very top of it represents the height of the water that came in the vicinity of the Airham Elementary School. Okay, and just for perspective, it's a 9-meter inundation depth, and these are adults standing at the bottom. So we're talking very big events, very deep water inundation, and that's roughly equivalent to what you're seeing in some of these plots through here with 8 to 12-meter inundation depth. So a lot of water coming in, and in the end, what it means is that we really need to make sure that we're prepared. Okay, so how does this affect infrastructure? We see the forces that are going to cause failure among a lot of the various structures. So here I'm showing bridges, what happens when we combine hydrodynamic forces, which are based on the movement of the water, buoyancy forces, which are the tendency of an object to float in the water. And we see a lot of bridges that have washed away or have things on top of them and are basically unusable. Similarly, with hydrodynamic and damming forces, these figures we see here from Gary's presentation in 2015, hydrodynamic forces that are going to scale with the area, right? The more area you have, whether it's a wall through here or even debris that builds up and builds a wall through the structure, those are going to cause increases in the force, and these are forces we have to design for as civil engineers to some extent, right? And then we also see debris damage. What is debris? Well, nearly everything is debris in these tsunami events. And so we see what's left over after some of these events. You see a boat on top of a house. You see all of the houses have kind of turned into their individual components. And so these are the things we have to think about as we're going through the design process, but also as we're going through the sort of life safety process and that thought. And so the question then becomes, is the US equipped to handle this? So I've shown these two pictures on the left already. Those are from the 2011 Great East Japan tsunami. On the right, you see Hurricane Katrina. And so similar type of response to a large fluid loading event, whether it's the tsunami or the storm surge. Now, physically, they're a little bit different. We see the storm surge moving much slower. You're going to have the bridges have essentially been picked up and put back down as opposed to completely washed away. But conceptually, we're seeing this damage be consistent. And so the answer is the US equipped to handle it. We're working on it, okay? And so one thing that gets asked is, well, we live in a very high seismic region. That's a little bit different than some of the more tropical hazards. But if we compare, this is a figure that was, my reference is missing, but from Kasten and some researchers that showed that for shorter buildings, you actually get higher loading. This base shear term here has to do with the kind of the magnitude of the total force that's being imparted on the structure. And for buildings in the 2, 3, 4-story range, we see comparable or even exceeding what the seismic demand on a structure would be. So these are very large loads, even in a seismic region, that we have to consider. Okay, now I like to show just quickly a video, and I'm going to talk through it, and hopefully this will help to motivate kind of what we're going to talk about here today. And so this is 3 separate clips from a CCTV video, okay, of people as the tsunami comes ashore. We see the chaos. We see basically everything turning into debris. Okay, what was a kind of a sort of quiet intersection has turned into anything but, as the different boats, cars flow through, the water comes flowing through, and you're just seeing full inundation. And this is sped up, but it's, you can see kind of the speed with which something like this could happen, okay? And so in the moment, figuring out what I need to do when something like this happens becomes important. Now this second video shows a bridge, and we see the water coming up. It's going to overtop the structure, okay? And so here what we need to be thinking about is not just the magnitude of the water. There's a house that's going to come and cross over the bridge here, okay? We see large-scale debris. We see lots of water coming over the bridge. But after everything subsides, the bridge is no longer traversable, okay? And so a second thing we need to think about are if we do guarantee life, or not guarantee, but if we do help with life safety issues, are we going to be able to get to people after the event? Are we properly considering whether or not these individual bridges, which sometimes serve as lifelines along the coast, especially within our Washington state, then that's something we have to think about. And then lastly, do you know where to go? And I think that's a big part as well. Do we know where we're supposed to go? Because it can be very chaotic, and you can see here a car that barely got out in time, but understanding where we need to go with our, whether it's through evacuation or vertical evacuation structures, things like that. Okay, and so kind of the last 2 motivating slides that I have here are going to be, what do we expect during a tsunami? Okay, we can expect that things are not going to be even remotely like we usually experience them. Okay, what's a typical day-to-day operation here on the left, whether it's kind of within the community or driving across a bridge, it changes very quickly, and it doesn't go back to normal right away, right? You have all this water, all this debris that's really affecting things. And so being prepared for how we can react in real time to that. And then also, what can we do before a tsunami? And I think that's what we're going to be talking about some today, is being prepared. Our roads become basically unusable. We need to know where to go, whether it's an evacuation structure that we have in town, whether it's high ground. This is from Chile in 1960. where people just went to high ground. But whether there are going to be these options for you. It's up to us to educate the community so that we know where to go, how to get there. And so with that, we're going to lead right into Dan talking a little bit more about some of the logistics of putting this together. But I thank everybody for their attention here.
Thanks, Mike. Are you good, Dan? You're muted.
Hello, can everyone see my presentation, your audience view? Thank you so much. In this talk, just picking right up where Michael left off, I describe an effort to plan for tsunamis, which are really rare. In this case that he was describing, a 2,500 year recurrence rate, unpredictable but really catastrophic event, as we've also seen very recently. But by viewing them as part of a suite of coastal hazards that have varying levels of severity and frequency. And that might also include more continuous and gradual environmental changes such as sea level rise. Oops, sorry. The work is really highly interdisciplinary, involves a convergence between geoscience and hazards-driven research and socio-technical systems-driven research, which seeks to understand how people make use of the science and respond to the hazards and incorporate the uncertainties involved with the scenarios and modeling that we need in order to for what hasn't happened in this particular part of the world in living memory. The city of Westport, the main focus of this convergence, is a coastal city located 150 miles southwest of the city of Seattle. Surrounding Westport is South Beach, an unincorporated area of Grays Harbor and Pacific counties that includes the Shoalwater Bay tribal lands and is roughly coterminous with the Acosta School District. Like much of the Washington coast between the Olympic Peninsula and the Columbia River, the coast consists largely of extended sand spits with communities at some distance from the nearest natural high ground. These communities are especially vulnerable to tsunamis. State emergency management policy and federal funding requires that evacuation planning and vertical evacuation structure design use a maximally severe Cascadia subduction zone event scenario, which currently has this long recurrence interval of 2,500 years that Mike mentioned. The map to the right shows inundation, the tsunami inundation modeled for such an event in and around South Beach. And the first vertical evacuation structure to be built in North America in response to this planning is the Acosta Elementary School in South Beach, just outside Westport. It predated the current federal funding program and was built entirely with locally generated revenue from a tax levy based on property values. And really represented this an incredible level of political capital and long-term thinking on the part of the community for the safety of their and future generations of residents. More vertical evacuation structures are needed in order to save all the lives that currently are lived out in this environment, and more work needs to be done to prepare these structures to shelter residents for multiple hours or even days after the event, including food and medicine supplies, sanitary facilities, and communications. And before a disaster strikes, there's a need to familiarize more community members with the space and structure by making greater use of it in everyday activities. So this is that sort of situational awareness and understanding in advance of where to go based on what is happening around you. The science of locating these structures and planning for the sort of maximal accessibility is ongoing and is quite complex. But our goal with looking at more than this very worst case event was to determine what strategies are really most appropriate for the very worst life-saving needs in the worst case, and which strategies might be more appropriate for the more probable events, preparing the community for change in response to a variety of hazards. To do that, it's really important that communities understand what it is that they value, what is the basis of their identity, and knowing that although they face an existential threat, they have lived through quite a history of environmental change already and have responded to that creatively through infrastructure investments and other land use decisions. And so generating the most creative and robust responses to this hazard information takes a certain protocol of development, development planning and discussion that we have generated over multiple years, about 10 years, working with communities around the Pacific Northwest. And that uses both qualitative sort of focus group type of discussions with quite advanced participatory GIS tools to layer complex data that people can respond to and work with. Among those data are these different scenarios. And we want people to understand that while the 2,500-year event is mandated by FEMA and the state governments for planning and funding for evacuation and life safety measures, it is the worst case, but it's not the most likely case. And there are likelier cases, including the one that last happened in this region in 1700, that are not quite as severe, but certainly need to be planned for, and may be the focus of planning for life critical decisions, such as where to locate certain commercial facilities, where to plan for roads and bridges. And then in addition to that, we have sea level rise, which is even less severe, but even more probable and also gradual, and we can see it happening on a year-to-year basis almost. The result of looking at this suite of hazards and seeing the worst case tsunami as one of them is that you can then layer your strategies. So the most life-saving critical strategies, such as vertical evacuation, still need to have some kind of daily value and enhance daily life in the community. They can't be just absolutely pure purpose-built structures, because it could be a very long time before they are needed. And the investment has to make sense to the community. So just to show one example of a student design that we have tested out with community input and with very place-specific, very localized modeling of the wave behavior around the topography. This is Westport City Park dune vertical evacuation structure as a bridge. This is completely envisioned, but it responds to the very latest modeling that's been done of the wave behavior. And what it does is it connects two of the rare naturally occurring high ground, high enough to be above the wave in the worst case event, that is closest to the marina and the population centers in the peninsula. And you can see here how it would function for daily life enhancement, become a place, and yet also be above the level of the inundation if a wave came through, and also provide enough supplies for people to withstand that event for a number of hours afterwards. Finally, this kind of planning also integrates with comprehensive planning, land use planning in the town for long-term strategies. So some of these involve accessing higher ground outside the city limits, might include annexing land into the municipality, changing the tax base. But providing access to what is currently private land, accessible only by forest roads on high ground, but that those eventually become, over the medium term, sites for recreational facilities, some infrastructural investment, camps, resorts, places that people wouldn't necessarily use in the town on a daily basis because they're very far from the current economic center of the town, but that might gradually, or if an event such as this were to take place, become the site for resettlement of the community. So that's sort of an overview of the near and long-term planning that we've been doing using this approach. Thank you, and Anne is going to take over next. If I can stop sharing my screen for her.
Great, thank you, Dan. Let me share my screen. Oops, I did the wrong thing. Let's see. Okay, can you see that okay? Great. Good afternoon. I'm delighted to be able to contribute to the discussion today on mitigating tsunami risk on the Washington coast. This picture shows a deep ocean assessment and reporting of tsunami, or DART buoy, which is part of the DART network of buoys that makes the U.S. Tsunami Warning Centers a valuable resource for coastal communities, not just in the U.S., but globally. Tsunami warnings are one type of risk communication that I've had the privilege to work on with an aim to help protect communities and make them more resilient. Here's a diagram created a few years ago by then doctoral student Nasser Marafi, who was in your department, who you'll see standing at the whiteboard in the last slide I'll show you today. It shows where tsunamis, you can see here, fit into the hazards research that we conducted in the NSF-funded M9 project that you've already heard about from Dan. And it gives you an idea of the interconnections between studies of subduction zone earthquakes, tsunamis, buildings and infrastructure, warnings, and community planning and resilience. This perspective continues to inspire our work. The significance of risk perception in all of this, including for engineers, is illustrated by a recent interaction I had. A scientist at a federal agency recently relayed to me, after attending one of our Cascadia Coastal Hazards Research Coordination seminars this spring, that he had been to the Pacific Northwest coast only twice, both times in the last 5 years. The first time was at Cannon Beach, Oregon. There, he and his wife noticed on a walk close to their inn a sign in a parking lot that was a tsunami warning alert. At the time, he noted, "We read it with amusement, not having yet any knowledge of the New Yorker article." He went on to say, "It was on a second visit that we got the big story on earthquakes and tsunamis, and a memorable dose of tsunami evacuation training. The training was, in brief, something like this. After the earthquake, there might be 15 minutes before the tsunami hits. During this interval, we were to run up the hill about a quarter of a mile to the meeting point at a grill at the top of the hill. This somehow caught my attention. Seemed like death was a possibility. Subsequently, my attention was directed to the really big one in the New Yorker. And if you haven't heard of it yet, you might want to take a look at it. When we surveyed people at the time, about a third of the population of Washington State had either heard of the article or read of it. Then he noted, regarding a slide from Harold Tobin, who's the current director of the Pacific Northwest Seismic Network and a UW faculty member, I see on Harold Tobin's slide, giant earthquake, 15 to 25% probability in the next 50 years. Somehow, that is not very reassuring to me. My wife is unlikely to plan another trip to the Pacific Northwest coast for us due to the tsunami threat. I asked a Pacific Northwest coast colleague about how she tolerates living in the presence of such a threat. Her answer seemed to be that the location is so beautiful, it overcomes the concern of a threat that may not come in our lifetime. Some of you may recognize this related graphic, which Sandy Doughton published April 13th, 2015 in the Seattle Times. The study it was from was published in the Proceedings of the National Academy of Sciences by geographer Nate Wood of the United States Geological Survey with several of his colleagues. Nate has conducted extensive modeling to estimate evacuation travel times to safety, some of the kind of walk times that Dan also showed, as a way of describing population vulnerability to tsunami hazards. Many of the news stories about this study sported titles like "Walk Fast, Don't Drive to Safety." One of the apparent outcomes of NATE's analyses was increased interest in vertical evacuation structures, especially in places in red. You may be able to see now that the red dots, which designate communities where successful evacuations are unlikely, include Ocean Shores, Grays Harbor, and Long Beach, Washington. Increased interest in vertical evacuation structures in Washington coastal communities illustrates how research conducted in interdisciplinary social and behavioral sciences can influence both research on and demand for engineering and planning. To put tsunami risk perceptions and warnings in context, here's a diagram from the National Academy's report on tsunami warning and preparedness. This is a report that M9 colleague Brian Atwater, who actually dated that 1700 tsunami, and I helped write, as did Nate Wood. Nate and a colleague, Dennis Milletti, put the initial version of this diagram together for the committee, which shows the components of an integrated tsunami warning system. Here on the left, you can see risk assessment. Risk assessment includes all assessments required to effectively plan evacuations, and that includes tsunami source determination, inundation modeling, and evacuation mapping, and to prepare the communities to evacuate in the event a warning is issued or received. Risk assessments identify needs for public education. Public education aims to ensure maximum preparedness and a public that knows what to do when it receives a warning or feels the ground shaking in the case of a near-field tsunami. Threat detection comprises the continuous monitoring of the natural and technological environments that could create an emergency. The DART buoy that I showed you is part of that monitoring. Public response is the ultimate outcome of the integrated warning system, and it integrates public education, threat detection, natural cues from tsunami triggers, and warning management. This original framework for the M9 project on Cascadia subduction zone events and related events, including earthquake early warning, takes a more comprehensive perspective on these risks, putting both tsunamis and warnings into the broader context of the social, built, and natural environments, and the interventions to reduce risks that can be taken at shorter and longer timescales, including, for example, changes to infrastructure and building codes in the long term, as Dan described. In the M9 project, we focused both on warnings as well as communicating tsunami risk and uncertainty for planning purposes. This afternoon, I can share a few new preliminary results from follow-on research to illustrate the social context for earthquake and tsunami risk perception, communication, and mitigation in Washington state now. As many of you may be aware, on May the 4th, Shake Alert, the USGS earthquake early warning system, rolled out in Washington state. In February, in February, we conducted a baseline survey to assess earthquake experiences, risk perceptions, and expectations, and opportunities for Shake Alert. I'll show just a few of these ABCs of Washington state risk perceptions and representative of the adult population of the state. Bear in mind that coastal county populations differ a little from other areas of the state. For example, Grays Harbor's population is a little older on average, but it's still quite diverse. So first, and you'll see here on the left are the percentages of respondents, and this is earthquake experiences. Just over 80% in Washington reported that they had personally experienced an earthquake. And the modal experience was mild shaking, with a few, under 20% in all, having experienced strong or violent shaking in their lifetimes. From other surveys of Washington state residents, we've learned that most felt little reaction, excitement, or some fright, not strong emotional responses. Still speaking of experience, of the 80% who had reported experiencing an earthquake, the vast majority stated in response to this select all that apply question that they had experienced no injury, damage, or loss from earthquakes, personally or socially. Although the modal response was neutral to this question here on the left, across both those who had and hadn't experienced an earthquake, almost half agreed or strongly agreed that a damaging earthquake will occur in their city or town in their lifetime. And the scale goes from light gray to strongly disagree to dark blue to strongly agree. Not shown here is the fact that those who had experienced an earthquake were more likely to agree or strongly agree than those who had not. People were about split on whether an earthquake would happen near them if it did happen in Washington, and the vast majority thought a big earthquake in their city or town would in fact impact their lives if it happened. Experience mattered for the responses to each of these questions. We asked people if they had heard of Shake Alert, and in Washington, 11% in February said that they had, and that's shown in blue. The 89% in stripy red reported that they had not heard of Shake Alert. We then asked in a select all that apply question whether they knew about what Shake Alert does, or guessed it might do, with the question tailored depending on whether they'd heard of Shake Alert before, shown here in blue, or not, shown here in the stripy red. The majority thought Shake Alert sends a warning that an earthquake is approaching, shown here, which it does do, and this is correct. But note here also that many held the mistaken belief that Shake Alert predicts earthquakes, which it does not do. Also notable and illustrating needs and opportunities for continued education and outreach is that only about a fourth overall knew or guessed that Shake Alert is operated by the U.S. Geological Survey. We then showed those who had not heard of Shake Alert, remember this was almost 90%, this description of the Shake Alert system, which is available on the Shake Alert website, shakealert.org. As you can see from this slide, survey participants overwhelmingly agreed or strongly agreed that Shake Alert would enable them to mentally prepare themselves, physically protect themselves from earthquakes, to help other people nearby, and would give them some useful information about the earthquake, even if they didn't feel the shaking. The 11% who had heard of Shake Alert were more likely to strongly agree than to be neutral on these statements. One could conclude that the awareness of Shake Alert made them more optimistic about its usefulness. Experience, even vicarious experience, and influences awareness, and that in turn influences attitudes towards risk and attitudes towards measures to reduce risk. Note here that people would like to know the shaking intensity they can expect to feel, but they are almost equally interested in information on additional hazards like tsunami, as well as on guidance on what action to take. This, in closing, is a picture of an interdisciplinary workshop hosted by the M9 project, in which we explored how to convey tsunami inundation risks in ways that would help coastal communities address the questions they have about building and protecting community infrastructure and assets. And this predated and led into the workshops that Dan talked about. Standing at the whiteboard, you can see on the left, policy student Alicia An, and on the right, civil engineering student Nasa Marafi, an engineer with a keen appreciation of interdisciplinarity. There is no substitute for engagement and dialogue to achieve effective communication of values, needs, and decision priorities and constraints for community members and for those with technical expertise. Well-designed communication and decision support tools can foster interest and facilitate better discussions. That requires several varieties of scientific expertise: engineering, earthquake and tsunami expertise, communications, decision and risk sciences, and planning. Thank you.
Thanks, Anne. Are you ready to go, Representative Kilmer?
I'm ready to go.
Excellent. It's all
Thanks again. The challenge of going forth is covering some terrain that's been trod already, but I want to start by just sharing two stories from the district that I have the honor of representing. And the first highlights the size of the task at hand. It was just 2 years ago. I was meeting with the Ho tribe, a tribe that has known the coast of our region as their home since time immemorial. But in recent years, as the threat of rising sea levels and more severe storms and the threat of tsunami have become more acute, they've begun the process of moving to higher ground. And they've identified land to move to and have even built a fire station on the site of their future home. And the tribal chair explained to me that the station doesn't yet have water or basic utilities. And I asked, well, do you have supplies there? And he tells me that the federal government has supplied one item through a surplus DoD program. They explain they've given us 100 body bags. The second story highlights some progress we've made, and you've heard about that already. I'm standing 53 feet above sea level on the roof of the first tsunami-proof vertical safe haven structure in North America on the top of Acosta Elementary School. In the event of a Cascadia subduction zone earthquake, it would take nearly 100 minutes to evacuate the kids in the vicinity of the school to higher ground. But with this new structure, the students and staff of both the elementary school and the adjoining junior-senior high school, a total of 700 people, could climb up one of the 4 staircases to the roof with room for hundreds more. It is a feat achieved through local officials and through government working together. So, as someone who was born and raised in the district that I now have the honor of representing, I think I can say on behalf of many folks in our region that the threat of an earthquake and the massive tsunami that would come with it looms large in our lives. Thankfully, we're starting to make some progress in ensuring that our communities are more prepared than ever for when that does happen, in working to ensure that we have more hope for more kids and removing that dark symbol of needing to use body bags. As you just heard in early May, with the rollout of Shake Alert here in Washington, we are celebrating a critical milestone in our region's years-long effort to develop a comprehensive and fully operational early earthquake warning system that will be our eyes and ears throughout our region. You know, the experts at the U.S. Geological Survey, along with the incredible team at the University of Washington and a coalition of other state and university partners, have worked together to build this innovative system. The men and women working at the UW are driving the innovation needed to make progress on this front. But to make this cutting edge system a reality, they needed the federal government to step up and be a partner too. And as a member of the House Appropriations Committee and as a representative for this region, I've been working since my very first day in Congress to do just that. That includes successfully securing $25.7 million in federal funding this past year to complete this incredibly important milestone. So today, with the Shake Alert system online, it brings me a little relief to know that folks across our region will have a few more critical moments to get out of harm's way. Let's just think about why this matters to every single one of us sitting on this Zoom today. You know, imagine you're a surgeon holding a scalpel, or a teacher with a room full of students, or a family at the beach. A warning, even just a few precious seconds or minutes can save lives. It matters. Imagine you're on Highway 16 and about to cross the Tacoma Narrows Bridge, or you're a worker at the Puget Sound Naval Shipyard, and you're about to enter a building that's 130 years old and hasn't seen adequate seismic improvements yet. Imagine you're a crane operator at the Port of Tacoma, getting that notification that an earthquake is about to hit and having enough time to get down to the ground and out of harm's way. Time matters. Imagine you're a member of one of the 4 Native American tribes in my district. We're now having to move to higher ground to avoid the threat of tsunami and sea level rise. Those precious minutes could make a real difference. Or you're a resident of communities like Ocean Shores or Westport, which you heard about earlier, where even a handful of seconds of warning can be a difference between life and death in a catastrophic event. So this matters. It matters to everyone on the West Coast. And I'm just so thrilled that the system has finally become a reality. But we know there's a lot more work to do here. We need more tools in our toolbox to help communities become more resilient to the growing number of everyday threats, like rising sea levels and more severe weather events that are the direct result of climate change. That's why I'm very glad, very grateful for the UW's leadership in advancing the research and developing the technologies that help make our communities safer. And that's why I'm so honored to join you all for this important conversation about how we can use this expertise to help shape federal policies to ensure that communities have access to these important tools. I believe now more than ever, there's real opportunity for Congress and the federal government to adopt policies that will protect our communities for future generations. As Congress works to advance a comprehensive infrastructure package, one of the things I'm working on is just to make sure that this bill prioritizes climate safe and seismic safe infrastructure so we can truly build back better. From addressing persistent flooding and stormwater runoff to improving nearshore habitat and removing failing culverts, we have an opportunity to improve resilience and protect public safety, while also meeting our region's environmental priorities and putting folks back to work in great paying jobs. That's a win-win. There may be even like 2 more wins there. It's like a win-win-win-win. So how do we get there? Well, first, we've got to put existing programs on steroids. Programs like FEMA's Building Resilient Infrastructure in Communities, or BRIC program, or NOAA's Coastal Zone Management Grants, and other programs. Those need to be on steroids. Both the BRIC program and Coastal Zone Management Grants provide the direct financial support that communities need to design and to construct more resilient infrastructure. But these competitive grant programs are woefully underfunded, each providing less than $100 million annually to address the needs of communities nationwide. On top of that, many of our most vulnerable tribal and rural communities simply do not have the capacity to compete for extremely limited funds, let alone develop and implement a comprehensive strategy to effectively mitigate against a range of natural hazards without additional support. So as a member of the Appropriations Committee, I've been working to grow these existing pots of money and to direct federal agencies to prioritize applications from these underserved communities to try to level the playing field. But the fact is, these communities need more coordinated and comprehensive assistance to make meaningful progress toward meeting their resilience goals. So that's why I'm working to create a new federal program that will help fill remaining gaps and address new challenges as they emerge. In our region, the Army Corps of Engineers already plays a critical role in providing the technical expertise and capacity building that our most vulnerable communities need, but they lack both the funding and the authority to do more than provide technical assistance. So that's why I'm working on a bill to grow the Army Corps' role by creating a new coastal resilience design and construction program to provide direct assistance to state, local, and tribal governments to develop and implement coastal resilience projects with an emphasis on nature-based infrastructure. This new program could be a real game changer for our communities by providing both the financial resources and the technical expertise that they need to mitigate against the threat of natural hazards and measurably increase resilience. Along those same lines, I'm working on a bill that would create a new coastal restoration and salmon recovery corps at NOAA to create the necessary resources and workforce to accomplish critical on-the-ground restoration, while also supporting skills training and other work experience to help build the next generation of coastal resilience experts. Building out this ready-made workforce with the technical expertise to execute projects is a key component to our region's strategy to address our most significant vulnerabilities and to ensure our communities can thrive for generations to come. But this kind of development doesn't just benefit the health and safety of local communities. There are huge environmental benefits as well. While there's still a lot of work to do to build this next major infrastructure investment, this undeniably represents our best opportunity to make the necessary long-term improvements to make our communities more resilient to natural hazards. So as I wrap up, I just want to end where I started, which is with a quick thank you. Thank you to the smart folks at the University of Washington for being incredible thought leaders who are developing the tools we need to keep our communities safe. I want to thank the Evans family for hosting this lecture. Dan Evans was such a difference maker, a governor, a senator. I call him governator, but so grateful to the Evans family for their focus on this important issue. And thanks to all of the young folks in the audience who want to be part of the next generation of thought leaders to continue this important work. So I look forward to helping answer any questions you all might have, and hope that any of the questions that are related to science or engineering will be answered by the smart people in the other boxes on my screen. So thanks, everybody.
Thank you all very much. That was a wonderful introduction to these issues. There are a number of questions that are in the Q&A box. I'm gonna ask them to all of you and let you decide who might be the best person to answer. So the first one is there a plan to deploy ocean bottom seismometers offshore? Such systems can help both tsunami and early earthquake warning. Any of you know that?
Well, I can say that there have been a lot of discussions of this, and I suspect that possibly Representative Kilmer may know as much as any of the rest of us, but I know there's a strong interest in this on the part of the scientific community involved in Shake Alert and also in Cascadia subduction zone science. And there have been several efforts to try to promote this, but it's very expensive work, and it hasn't happened yet. And so that's about where I think it is.
Thank you. It is important to note that the modeling is not for a worst case scenario. The building code sets a risk tolerance threshold of 2% probability of exceedance in 50 years. That means that there's a 2% chance of a worst scenario in the next 50 years. How do you think that issue relates to these evacuation structures and thinking about relocating or design of significant community structures in this region? Anybody want to take that one?
I think so you mean just the basic probability of everything? I think so go ahead, Laura.
Oh, I was going to say, it kind of, that your response kind of builds on my question of how do you engage the community to decide where to spend the resources? Because I imagine that from a straight engineering perspective, there are certain things that make the most amount of sense to save as many lives as possible, but those may not necessarily actually work within the community structure. So I think that kind of goes to this issue of how do you draw the line on 2% and 50 might not be good enough?
Dan, did you want, I know that's been in some of the community-wide discussions, is that?
Sure, I'd be happy to take a crack at that. I discuss this all the time when I speak with local planners, officials, and residents, because there's an even greater probability, they estimate between 10 and 20% within 50 years of an event like what happened in 1700, which isn't the worst case. It's about a 500-year recurrence interval rather than a 2,500-year. And so if your risk tolerance for some things is going to be as low as 2%, then those things have to be really, really, well, they have to be two things. They have to be what you really value extremely highly, the most above all, which generally speaking is life. Also, they need to be incorporated in what you want to make. And in any case, a Acosta School vertical evacuation structure was made functional for this kind of event. Yes.
You were breaking up a little bit. Maybe you could go back just a little bit to, I think it was what's most important beyond Leipzig.
Oh, okay. My internet is not so good. I'll turn off my video. Is that better? Is that better? Okay, so if life safety is the most critical value, which you value at a 2% rate probability for 50 years, then you are not going to be so concerned about economic values, property values, anything else really. It's just saving lives. But remember, even that is going to be an extremely expensive proposition unless you can incorporate the investment into other projects such as hotels, schools, hospitals, clinics. And remember that the Acosta School was made a vertical evacuation structure with about a 15% premium on top of its construction cost, just to rebuild it as a normal new school. So it's not, if you're building purely purpose-built vertical evacuation structures that don't have any other function or value in the community, that is extremely expensive to do. But if you are incorporating it with other projects, then it may be much more feasible.
Yeah, thanks.
And maybe I could elaborate a little bit on that, if that's okay. So one thing that Dan noted is that people may have missed is that this is, if you think about a single scenario, that doesn't represent the range of events that could happen that are close to that scenario. So the 1700 event was also a quite large event and enough to cause a lot of problems. So thinking about it's important to think, and also Dan talked about the climate change, and the storm surges that you can expect with climate change are going to be increasing in inundation depth. And so you can think about addressing multiple problems that are related at the same time, while focusing on what you can do to maximize the community values and assets that you have. And it's important to think about those together so that you're not just focusing on a single scenario and not just focusing on the potential loss, but also on the potential benefits and gains to the community and the planning process.
Thanks, Anne.
Yeah, just real
Thank
quick.
you.
There's a comment in the chat from Ian Robertson as well, who's been helping lead up the ASCE 7, noting that the 2,500-year event is kind of a baseline for us for a lot of the built infrastructure. But for critical structures, we have ways to increase that, including for evacuation structures. We take those values, we increase them by 30% for the height above sea level, and then we add another 10 feet, right? We're taking a lot of that into account for the, as the structure is deemed more and more critical, we have ways that we address that. So thanks, Ian.
There are a couple questions here that focus on the idea of raising awareness and what can we do to raise awareness, and how do we loop in and make sure that consultants in the construction industry are also understanding this risk and the importance of having these kinds of structures, or having these kinds of, I guess it's primarily structures that provide the evacuation safety. I think that might be yours, Anne.
I was thinking it was Mike's. Yeah, I think that a point that one could take away from the all these different events is that communication and outreach programs do matter, and that you can achieve quite a lot by increasing people's awareness. Once you've increased people's awareness of the kinds of events, we did another survey where we asked, we were trying to figure out how many people had seen one of those earthquake movies. I'm forgetting which one it was now, but it was San Andreas Fault, I think is, or the San Andreas. Yeah, and at the time there was a different structure for Google surveys, and so they accidentally had committed to collecting 1,700 responses for us, no, 17,000 responses for us to figure out the percentage of people in Washington State who had seen the movie. And it was about, I don't know, it was a very low percentage, it was like 2.5 or 3% or something. But what we found is, because we had enough responses, we found that those people who had seen the movie actually were more aware of earthquake and tsunami risks, and were more concerned about them, at least temporarily, than those who had not seen the movie. So even simple exposures to virtual events can help raise people's awareness. And all of these discussions and the outreach around Shake Alert will help people become more aware of the potential for these kinds of events. And Shake Alert, as Representative Kilmer pointed out, is an important component of letting people know on the coast that there is a potential for a tsunami. As soon as you know there's potential for an earthquake, that means there's a potential for a tsunami. So, so all of these specific things matter. It also matters to just continuously engage in these discussions and to make sure that professional practices are imbued with a conscientious awareness of hazard and risk planning and management. And there, I think this goes more to maybe Mike's professional standing, but there are the more discussions that we have around these kinds of issues. I know at the M9 project has made a really strong effort to reach out to the construction and consulting industry around building and construction, as you know, as you guys know, and we had quite a few events that were engineers, seismologists, and construction contractors talking about these things together. And so that has helped raise the awareness in the state of these kinds of things as well. So each step matters. I did hear today that Washington State is still really pressed on funding for example, EMD to be able to be involved in communication, education, and outreach. They're doing what they can on a shoestring, so funding's always an issue, and it's difficult. And we really appreciate Representative Kilmer's conscientious and constant pressures on this.
Are there organizations that our students or others that are here where they could volunteer their time? Anybody know? We'll go with no, and that's something that we should investigate. And when somebody from the audience or the panel finds out, then we will attempt to communicate that back out.
They can always join ERI, right? The student groups.
Yes, that's right. We have a student chapter of EERI. Good place to start. So there's a question for Representative Kilmer. Very glad you want to put brick on steroids. Would this be in the multi-billion-dollar range, 25 to 50? Also, will brick standards be adjusted to allow new construction outside of the tsunami inundation zone? Currently, brick rules are essentially a slight upgrade from PDMG rules.
Thanks for the question. I think in light of the fact that the Biden administration and Congress are currently talking about an infrastructure proposal, something in the range of $1.5 to $2 trillion. Looking at something in the range that you just suggested seems pretty reasonable in light of in light of the need. As I mentioned, right now you're looking at programs that are less than that are in the 100 million-ish range. That doesn't meet the needs of a single community, let alone all of the communities along the coast that are vulnerable. As for the second part of your question about whether brick should be reformed, the short answer is yes. I think you're going to see more and more engagement on this, not just with regard to funding levels, but with regard to the use of the dollars.
Question. Our questionnaire survey to some Oregon and California residents shows that the majority of people don't intend to evacuate by foot, but rather choosing car, even though we advise to evacuate by foot. I wonder if it's the same in Washington. What are the potential obstacles to education and communication and outreach?
There might be somebody else here better equipped to answer this. There's been quite a bit of work on the coast on tsunami perceptions, and I have not participated in those specific surveys. Professor Mike Lindell, who's associated with urban design and planning at the UW, has worked on that. And we have also seen David Johnston and colleagues who are associated with GNS in New Zealand have worked with student groups and from a variety of places and done surveys along the coast. I would guess from what I've seen in our own surveys and from their work that the results are similar along the Washington and Oregon coasts. And just thinking about how people think about trying to get away from something quickly, cars are what people think about. I mean, they think that that's faster. They may not be aware of Mike's results, for example, of these videos that show that in fact, routes that we know are lifelines may be obstructed or impassable in the case of a tsunami, and may not be thinking about the fact that the earthquake may have damaged them severely as well. So it's, yeah, that's a problem. Everybody's well aware, including EMD in Washington and federal agencies, that we need continuous education and outreach on these points. And I don't think there's any magic bullet. There are lots of creative ideas for ways of increasing understanding of walking and running evacuation routes. For example, in New Zealand, they painted blue footprints along the evacuation routes up the coast so that vacationers and others would see those. And so if there's funding, there are definitely people who are working on this and interested in working more on it. And it's an ongoing learning process as to how to do this better.
How is climate change included in design of these evacuation structures? Or we were talking about coastal engineering and coastal risks. So obviously on the Gulf and the East Coast, then climate change has a huge impact in terms of storm surge from hurricanes, et cetera, but it must also have a significant impact on expected water height for tsunami. Is that included in the design process these days? Please, Dan, go ahead.
Well, I'd like to answer this just because I'm working with a group of students and members of our other, our modeling colleagues here at the university who with the, both on the sea level rise side and on the tsunami side, and I believe they are right now doing the very first joined modeling. So this has not been done. And whether, how it affects the design of structures that are, or the engineering standards, I think is a question that needs to be looked at again when they do this work. There's also to bear in mind, the effects of subsidence or uplift. So when the earthquake happens, the ground level changes as well. And in some parts of the coast, that actually exacerbates sea level rise and the height of the tsunami. And in some areas, it could actually neutralize some of those effects. And I know that the subsidence, it has been taken into account because it's seismic. But I don't think sea level rise has. But there's a longer time horizon involved with sea level rise too. So if we're not talking about the next 50 years necessarily as much as we were talking about 150 years perhaps.
I'm not enough of environmental engineering to question those numbers, so I will leave it to others in the audience.
In principle.
I will have a note from somebody in the audience that one volunteer opportunity is CERT training and community response team. At what point in the community development process can private development be steered towards incorporating vertical evacuation features into their structures? Whose responsibility would it be in the local government to apply leverage in that direction to prevent prime evacuation locations being overlooked during private development? Somebody's developing a hotel. Who pushes them that they should make this a vertical evacuation structure? I think Representative Kilmer might be the best one to answer something like that.
I was worried that you were going to say that. Well, listen, obviously government has on occasion changed building standards, right? You have seismic standards now, for example, that didn't exist previously. So when you're doing new construction, there's an expectation that it meets a certain standard. At some point, and particularly if you're looking at a very substantial new development, there may be a decision made by local government or by state leadership to have a requirement in that regard. That doesn't exist now, in part because, as we've acknowledged, there's a substantial cost tied to it, and which is part of the reason that we're working at the federal level to provide more resources. Simply making it a responsibility of a local project may be difficult, just given the scale of what we're talking about. But having more of these on the coast to provide a safe haven in the event of catastrophe, I think is really important. And whether that be required of specific development, or whether that be an obligation that local communities are taking on their own with hopefully support from state and federal government, it needs to happen.
Is there an opportunity for public money to provide more of a carrot rather than a stick? So if you make it a vertical evacuation, then there's some money given to you or some tax relief or whatever. Is that an option?
I think so. I think there is an opportunity to either through the provision of direct resources or looking at some sort of tax treatment, you might be able to do something like that, not just from a regulatory standpoint, as is currently the case with seismic requirements.
Let's see, there was another one down here that I wanted to ask. We're currently building a jetty with the expectation that it should be operable after the M9 Cascadia tsunami effect, but all the other ancillary works do not have such a requirement. Does this make sense in terms of operability? Since if the main structure is standing, I imagine that it will not really be operational if all of the supporting structures is not. So the main structure demands enormous resources, which the budget may not be able to afford. How can one judiciously decide on the extent of resiliency against such an abnormal event? So you've got a jetty that has these huge requirements on it, costs a lot of money. You've got other structures around it that don't have those requirements. How do you balance those things out? I don't know whether that's from the, I mean, that's obviously, I don't know whether that's from the community standpoint. I don't know whether that's from the engineering standpoint of how you look at the risk for the system as opposed to the individual component. Do you have any thoughts on things like that?
I think a lot of it's gonna come down to, owner's comfort level, right? I think that there's gonna be a baseline that the design code is gonna require for you for various components of a building or a building system. But beyond that, I think it's going to be a lot of the cost benefit analysis of what it looks like if this does get washed away. Are we able to practically within an individual owner's budget design for this, and that, yeah, it kind of becomes up to an individual for a private type of project.
Might just add to that. I was thinking Dan might say something, but I mean, hazard planning being integrated into comprehensive planning can help people take a broader systems perspective on this, and that can be very helpful. So, and may promote thinking about the systemic issue.
Yes, I was going to say, I mean, if you can look at all of the other effects of the event that accompanies that kind of earthquake, such as subsidence and uplift, coastal erosion, future coastal erosion, sedimentation, et cetera, then, I mean, that has to be all considered together. I would hope that no one's just looking at the structural integrity of the jetty itself under these circumstances.
And I'll just add, I think this underscores the value in having a holistic approach for communities, to think about the critical components, to think about the critical structures that need to survive.
On a slightly different note, what are the additional issues associated with these remote communities on the Washington coast, and what additional infrastructure is needed, or how do we address those additional issues?
Well, I think one of the big ones is lifelines, right? I mean, I think that you've got a lot of communities where you're talking about one or two points of entrance and exit, right? And so I think that these are smaller communities, and sometimes it can be hard for their voice to be heard over, Seattle and Tacoma and everything else. I think that's a big one, is how after the fact or after the event, how do we get out there and check on them? How do we get them supplies, things? I think that's a big hurdle, is just the idea of the lifelines, as we go through, and then also figure out, we talked a little bit before about the evacuation structures, right? From location to location, these communities are trying to get evacuation structures constructed in their towns or in their smaller communities. And so figuring out funding mechanisms for that, figuring out how to work with the communities to inform them of the necessity for these things, I think is also very important, right? It's all kind of life safety, and then post-event access to the communities. To me, that's the big hurdle.
You've all done a lot of work out there, and obviously Representative Kilmer, you live out there. What's the sense of how well prepared some of these communities are, and what are the next things that various communities on the coast need to do?
I don't think there's a strong sense that people are prepared. And, it's why we're working on many of the things we're working on. Listen, there's 4 coastal tribes that I represent that, as we sit here, are in the process of trying to move to higher ground. And that is a recognition that if things are as they currently are, there is substantial vulnerability. The largest employer in my district, I didn't even talk about this in my remarks, the largest employer in my district is the United States Navy. It turns out our naval installations are on the water. And, so there is great concern about resiliency by the Navy. When I sat down with their regions command and said, what's keeping you up at night? I was surprised that within the first 5 minutes, part of the concern was just resiliency of the installation. There's a recognition that in the event of substantial earthquake and a following tsunami, we have neither the tsunami-proof vertical structures in place to hide people, nor the means of quick evacuation. And we had a false alarm up in Nia Bay, and talking to people who during the false alarm were saying, gosh, I had to decide which kid to go get on which part of town. And I think it was a real wake-up call for people. It suggests taking action in some of the ways we've discussed today. That is not to say that we're not making progress. I think there is a recognition that the Shake Alert system can help buy some time. You're starting to see some of these developments, including the Acosta Elementary School. There are other projects that are underway on the coast, and I think there's enthusiasm about that. But there's a sense that this is a bit of a ticking time bomb, and that and certainly the New Yorker article was not bedtime reading. Certainly not for my constituents on the coast. So it highlights the importance of this work. The work that the University of Washington and other partners are doing is incredibly, incredibly important. And certainly part of my job is to make sure that the federal government steps up as a partner in that.
I'm going to add a couple of answers that have been provided by some of our others on engineers and such. So Ian Robertson from University of Hawaii noted that the idea of developers being given incentives to incorporate vertical evacuation, essentially perhaps allowing buildings to exceed height limits, which is a huge deal when you're building a new building. It is current practice to account for both coseismic subsidence and expected sea level change over the lifespan of a project when doing site-specific inundation modeling. So that aspect of it is incorporated. And that's also in ASCE 7. There was a couple, sea level rise was incorporated in the design of the Acosta School. It added about 2 feet over a 75-year lifespan, which is not trivial. Let's see. I think that's the close ones there. If I'm missing your response, I'm sorry. A couple of other questions. The GAO in 2017 issued a report suggesting that managed retreat funding should be concentrated in one agency rather than the various silos of HUD, transportation, FEMA, et cetera. Is there any momentum in Washington to actually do this?
I didn't catch the first part of it. What funding was?
It was the GAO. I don't know who that is.
Government Accountability Office.
Okay. Issued a report suggesting that managed retreat funding should be concentrated in one agency rather than the various silos of HUD. Is there any movement to do that?
I'm not sure. I can tell you, figuring out how to have, where you have kind of the alphabet soup, kind of co-owning things, that can be problematic because if everybody's in charge, nobody's in charge. So I think GAO may be onto something in that regard. Having said that, there's also, there's also work underway, and we're part of an effort in the appropriations process this year to try to have more of a whole of government approach to solving some of these problems, where there can be a single sort of lead, but that it's, kind of herding the cats of the various agencies. I say this, for example, with regard to tribal relocation. Right now, tribes are put in a rather untenable position of having to kind of work their way through the multiplicity of federal agencies, often without grant writers on staff. And, so part of our push is to say, this is a good role for example, in this instance, the BIA, the Bureau of Indian Affairs, to pull together all of those federal agencies and to have a whole of government approach to solving these issues. Well, that doesn't exist now. And I think particularly given the vulnerability of many of these communities, that needs to be a more common approach.
One more question for you. You talked about there being $25 to $50 million more funding for coastal engineering or reducing coastal risk. Hopefully that wasn't millions. How does tsunami risk balance out against coastal risk in the Gulf of Mexico and on the East Coast? I mean, there's an enormous amount of population there that is vulnerable to hurricane flooding. And we just saw the 20-foot tall walls in Miami in the newspaper. I'm guessing that tsunami risk might be, is it small potatoes in comparison?
Well, so I don't know if this is good news, bad news, or news. The reality is the Biden administration in its infrastructure proposal is looking at resilience, period. You know, resilience to, listen, I mean, I was at the lower village of the Quinault Indian Nation with their tribal president. They're now their tribal vice president. And she said to me, you know, when I was a kid, the ocean was a football field's length away. And she said, now it's our front porch. And she said, this village is below sea level. And so every time we see a storm surge, there's seawall breaches. I mean, we are frequently, particularly during storm season, on the phone with the Army Corps, asking them to go fix the seawall. And we have not yet had a restraining order put out against us by the Army Corps, but we're getting close. And that's not because of a tsunami. That's because of just the annual impact of more severe storms and rising sea levels. And that's a resilience issue too. And so and Westport and Ocean Shores and some of the other communities that have seen persistent resilience challenges, they need some help. And so that's been a big focus of our work with the Army Corps. It's part of our pitch as part of this effort around infrastructure. Even, you know, as we look at you know, you asked about the building standards for buildings. One of the conversations we've had has been with the Coast Guard. One of the common themes with these coastal communities is many of them have Coast Guard stations that are very vulnerable. And I've sat down with the coasties in Westport and said, you know, what's keeping you up at night? And other than the failure of the federal government to pass budgets on time, one of the things they said was, we're really conscious that we're in a very vulnerable location, particularly if there's a tsunami. So part of the discussion we've had is, you know, could the Coast Guard look at what would it mean to make these stations, one, less vulnerable, more resilient, but two, could you look at creating tsunami-proof structures on those stations? You know, these are things we're kicking around, just acknowledging that there's probably not a silver bullet to solving this problem. It's going to be more like silver buckshot.
Thanks. Does anyone know how frequently they do evacuation drills in the region? Have they done one? We're going to.
I wish I knew the answer to this. I should, but I don't. But I do think that there are variations. I mean, you can have evacuation drills that are local. So I don't know. We are planning for Cascadia Rising 2.0. And it's possible that there will be efforts of that sort too, rather than just involving more sort of community, higher level organizations. And we're talking about, for example, there's been some discussion, for example, of potentially aligning a shake alert practice drill with the Cascadia Rising 2.0. So that might be an opportunity to do some coordination around evacuation drills. It's difficult to get people to drill regularly enough. I guess the one place where you do see that is schools. And as we know from Japan, that can be extraordinarily helpful. And also the videos of what happened in Alaska.
Yeah. Okay, 2 more questions. What are some of the best ways to retrofit an existing building to improve tsunami performance? Are there relatively easy steps for homeowners and property managers for smaller tsunamis and floods? That's you, Mike.
Well, from the videos we've seen of homes, I don't know that there's a strong idea of a tsunami retrofit for a typical single-family home. I think that it's not really right now. The design is largely about life safety. I think that's really the primary focus at this point, and evacuation structures and critical structures, and the idea that we're going to design every 1- and 2-story home to withstand a tsunami is just not going to be practically achievable. And so, but in terms of kind of some of the engineering concepts that are out there, you know, some of the stuff we have looked at has been sacrificial floors, things like that, where you're really just kind of accepting the fact that you're going to lose the bottom floor of your building. So you design around that. Assuming, you know, again, just loss of area. I think that's kind of the big thing. The less surface area you have, the less there is for the fluid loading to build up. But yeah, I think in terms of individual homeowner property managers for what we would call a small tsunami or a flood, I think it's going to most likely be, you know, the status quo, but really just making sure that you've got safe ground, that you've got life safety handled, and that again, you know, when you have these opportunities, you know, sacrificial floors, things like that.
Okay, last question. Where do we get our Shake Alert app? Is it available?
Somebody else want to take this? It is available on smartphones and cell phones, and you can get it if you're on an Android phone. It's in the system. And if you want instructions on how to find it, probably the easiest way to do that is to go to Washington's Emergency Management Division, their website for Shake Alert, and they will tell you there are instructions on that website as to how to get the app. There's no app, I should say, in Washington right now. There's only ways of getting it through WIA, and you can get it through WIA on both types of phones. It's through WIA if you're on a phone that's not an Android. It's directly through Android if you're on Android, if I understand it correctly. But they have instructions on how to get it on both types of phones. Does anybody else want to add anything? It's available now.
Excellent. So we will leave you all with that. Go look for the My Shake app, or I'm sorry, the Shake Alert app, and thank you all very much. That was really interesting. I very much enjoyed the discussion. So thank you, Anne and Derek and Dan and Mike for spending some time and putting that together for us.
Thank you for the opportunity.
Thanks, everybody.
Thanks a lot.
Thank you.
If you all want to stay on for just a minute. I don't think there's a way that I can.
Should we stop the recording?